So in this lesson, we're going to continue working with organizing our equivalent ratios and rates into those double line diagrams and tables. With today's learning target, I can use my understanding of line diagrams, tables, and rates so I can solve real-world problems involving rates. And you'll know you've got it when you score at least an 85% on the assignment following the lesson. So we are going to be given some rates. We're going to read the problem carefully and we're going to follow the directions. So when you read the problem, you're looking for the units for the given rate. Remember, a rate is a comparison of two quantities or numbers. And those numbers, when they're a rate, have different units or words to describe what those quantities represent in the problem. So as you're reading, we're going to go back and circle the units in the problem, the words for those quantities. Once you have those figured out, then you write that rate in abbreviated word form as a fraction. And then you will set up the rate using the numbers that go with those units as a fraction. And then after you get that set up, you will set up your diagram and use the diagram to solve the problem. And when you're done, include the units on your answer. A recipe calls for 6 teaspoons of seasoning for every 2 batches of chicken. So you can see that I've identified the units in this problem. We're comparing teaspoons that we're going to put in our recipe to the batches of chicken we need to make. And my double line has been started for me down here. Notice that they put teaspoons to batches. So the first number line is going to represent the teaspoons. And the second number line is going to represent batches of chicken. And every time I want to make a batch of chicken, I need to throw another 6 teaspoons of the seasoning in so it tastes good. So off to the side here, I'm going to set up my abbreviated word form. I'm going to put T on top and B in the bottom, T for teaspoons and B for batches of chicken. And once I get that, I now set up my 6 teaspoons to every 2 batches of chicken. I want it to taste right, so I have to make sure every time I make another batch, I got to add another 6 teaspoons to it. Now we're going to come over here to create that double line diagram so that we can then answer these prompts using that double line diagram. So it's 6 to 2. I'm not going to find the unit rate on this because I can set up my interval using this right here. 6 to 2, I'm going to start as my first 2 numbers on my number line. 6 will go on top and 2 will go in the bottom. Make it a little smaller. So the 6, the teaspoons are on top to 2 in the bottom. So I'm just going to put that there. So I'm not going to count by ones in this. I'm just going to use the rate they gave me, and I'm going to skippy count on top for the teaspoons, 6, because every time I skippy on the bottom, I'm going to add 2 more batches of chicken. So every time I add 2 batches of chicken, I got to make sure I add 6 more teaspoons of that seasoning. So I am going to just keep going, and I'm going to go out here so that I end up with 5 units out. So I'm going 2, so I have 1, 2, 3. I'm trying to equal space them. It's not going to be perfect, but that's the concept. These are equally spaced because the intervals are the same on both the top and the bottom. We're going to skippy count by the same amount on top and the same amount on the bottom. Okay, so if I want to double what I have, if I'm making 2 batches of chicken and I want to double that, that's going to make that 4 batches of chicken. And if I double this batch 2, I have to double, and I got to put 12 teaspoons of that seasoning in. Now, if I want to triple this 2 batches, I'm at 6. If I want to triple, I got to triple the seasoning, I'm at 18. So I'm scaling up to create this double line diagram with my 2. I'm going to, I want to do 8 batches of chicken. I have a couple options with my table here. I could just say, I want to quadruple. So I'm going to multiply the 2 by 4, and I'm going to multiply the 6 by 4 to quadruple my recipe. Or I might just go to the 4 and say double it. That's 8, double the 12, that's 24. Because remember, all of these rates are equivalent ratios. That's the whole point of the table, is to create this equivalent rates or equivalent ratio table. If I want to scale this up 5 times bigger, I want to make 5 versions of this 6 to 2 recipe, I got to go up to 10. And then this would be, hey, if I multiplied this by 5 to get 10 servings, I got to multiply the seasoning by 5, and I need 30 teaspoons. So this might be someone who's having a huge party or a restaurant, trying to keep that recipe scaled so that it tastes good. And I know some of you might just go, it's just much easier to go count, skippy count by 2s, 2, 4, 6, 8, 10, and then go 6 plus 6 is 12, plus 6 plus 6. We don't want you adding to get your numbers. We want you understanding you're scaling your rate that you're given up or down to get these values on this table. That's the key to all of this. It's a multiplication or division relationship. That is the key. Now, we weren't really completely interested in the unit rate on this. Told you we're going to kind of bail on it, but you can kind of see that sometimes when you reduce your fraction, when you reduce it, here you're going to get a 3 to 1 ratio. Because 6 over 2 can be reduced to 3 over 1 by dividing both of these by 2. They have a common factor of 2. And then you can find all of the odd numbers in between using this 3 to 1 ratio. So even though we didn't put the unit rate on it this time, it's there. You just have to think and apply what you know about equivalent fractions and scaling them up and scaling them down. In this case, we went backwards and we divided both of these by 2. When creating these numbers, we were multiplying the 6 and the 2 by the same factor. Okay, now that we have that diagram out and some understanding of how it's working, we want to read this prompt. If you have 8 batches of chicken, how many teaspoons of seasoning will you need? Well, we can look at the chart and answer that question. If we have 8 batches of chicken, we're going to need 24 teaspoons. So that's the answer to the prompt. But I want to show you how it works when we set it up as what we call a proportion. 2 equivalent fractions are called a proportion. So again, we're just going to put the word form, teaspoons, to batches. Even though we have the number line and we can answer from the number line, we need to see it this way because that's coming in our next lesson. So we need to see how these things look as a proportion, set up as 2 fractions, okay? So we have, we're going to put our rate that we're given. It was teaspoons to batches, or 6 to 2. And then we're going to read the prompt and we're going to circle our units. 8 batches of chicken. How many teaspoons will we need? So now we're going to go, okay, we want 8 batches, and we're going to use a variable here for teaspoons. I'm just going to put it up here a little higher because we already have the answer. T would go here, and it would be 6 over 2 T. 6 over 2 equals T over what? And then from there, we just look at our chart. You might have known it just by thinking about it as well. You might not have needed the diagram because these are not difficult numbers. And you get 24 over 8. The numbers are going to get more challenging, so we're practicing with these easier ones to help you understand multiplication division relationships, scaling up, scaling down. So to get from 8 to 2, we multiply by 4. So we have to go, hey, what's 6 times 4? And we get that 24 this way as well. Using this, if we didn't have the number line, we could do this. So we find out that we need 24 teaspoons, and you're going to want to fit that in this box as neatly as you can. I'm going to write really small. And it's plural, 24 teaspoons to every 8 batches. So that's what we found out. And we used our diagram here because it was right on it. And but again, this is the next level. So we're using this to answer prompts to help us visualize, but I want to also practice setting up. Okay, this one says, if you had 30 teaspoons of seasoning, how many batches of chicken will you have? Well, again, the answer's right here. Our chart went out 5 and it cleared it. So we had enough on our number line to answer this prompt. But let's practice setting up a proportion, 2 equivalent fractions from the table that we can use to find the answer to this prompt as well. So when the numbers get tough, this is where we're going. All right, so we've got our 6 to 2 ratio that they gave us. So we're going to put 6 to 2 again. That's given to us. All of this right here is given to us. And then we're just going to use the chart at this point. And we want, and this, teaspoons, we know there's 30, so it goes in the top. And we're trying to figure out batches of chicken. There's our other unit. So I'm circling the units, I'm setting up the word form, setting up the ratio they gave me. And then this is going to be B for batches. It's going to put it a little lower here because we already know the answer is 10. And then we put our units back on so we know what we found. We found 30 teaspoons, write small, get it in that box neatly. This is so important that you know what you're finding and what you were given. I was given 30 teaspoons and I figured out 10 batches because that's our rate. Teaspoons to batches of chicken. All right, so that's what we're going to be doing in all these examples. We're going to set the diagram up and then we're going to use it. A diagram will have some of our answers, but then in the next couple problems, you'll see the answers don't fit on the diagram or they're not point blank given to us with the numbers we've written on our line diagram. All right, so on this next problem, it says if you have 5 batches of chicken, here's your batches, your units. So I kind of circled it over my number there. I'll make that a little cleaner. You have 5 batches of chicken, and they want to know how many teaspoons you need if you're going to do 5 batches. So when we look at our number line up here, we don't see the 5 up here. It goes 3, 6, 12. There's no 1, 2, 3. So we're looking at batches down here. 5 would be right in between dead center of 4 and 6. So that would be where your 5 would land. So just looking at the diagram to try to figure this out, I would have to do a little work in my head. I'd have to finagle some things and I would say, hey, I don't want to skippy count by 2. I want to skippy count by 1 to get to this. And if I skippy count by 1, I just have to go up by 3 from my previous number. So this could be 15 here. The other way to think about it is to say, hey, I need the number that's exactly halfway between 12 and 18, which is also 15. It's 3 away from 12 and 3 down from 18. You can add these together and average them. 12 plus 18 is 30, divided by 2 is 15. There's lots of ways, but we have to work a little bit at it because it's not directly given to us on this. So we could get the answer that way. The answer is 15, but let's also set up a proportion to show you how it looks as 2 equivalent fractions. So we're going to start with the teaspoons again over the batches. We always got to track the units. And we know the 6 to 2 was handed to us. That was given to us in this original problem up there. So we use it. This is all given to us. And we're also given 5 batches. So the 5 would go in the bottom because I'm scaling up from 2 to 5. And so I need to scale this one up by the same amount. Well, to get from 2 to 5, it takes a little bit of work because it's not, 2 doesn't go into 5 evenly. So we have to multiply by a decimal or a mixed number. And the mixed number we're going to multiply by is 2.5. 2 times 2.5 is 5. So that one isn't as easy to find with our diagram, and it's a little tricky to find here because you don't have the fact knowledge in your head, but you have a calculator, so you should be able to figure out what you're going to scale this up by. Your scale factor that we're going to scale it up by is 2.5 in the top and the bottom, and when you multiply 6 times 2, you get 12, and then half of 6 times 0.5 is 3. 12 and 3 is 15, but you're going to use your calculator anyway. But it isn't too bad to do in your head, and you end up with 6 times 2.5 is 15. So it's 15 teaspoons, so you're going to write teaspoons in the little box. Nice and neat, fit it in there. And then that's for 5 batches of chicken, so batches goes in the bottom. We've answered the question. So the answer to this question is 15 teaspoons. Okay, the next problem says if you add 27 teaspoons of seasoning, how many batches of chicken will you have? Well, 27 again is not on our top number line, but it's there. It's just not directly there. So I have to figure out it's between 24 and 30. And it's exactly actually halfway because if you go up by 3, you get to 27. And if you go down by 3, you get to 27 from 30. So it's exactly halfway. So if that's exactly halfway, then this has to be 9. So from our diagram, we can answer that question because it's built in, and you just have to think, though. You got to think a little bit about it. So, and there's other ways, again, to get this 9. We could use the 3 to 1. To get from 3 to 27, you have to scale up by 9. You have to times that by 9. So if we multiply that by 9, we also have to multiply the bottom by 9 if we use that unit rate, if we've identified that. Okay, anyway, we're going to do it as a equivalent fraction or proportion setup. Take our rate that we're given, teaspoons to batches, 6 to 2, and we know 27. They said 27 teaspoons, circle that unit, and we want to know how many batches. So my variable is going to be B for batches. And I'm going to put the 27 up here with the teaspoons. This just helps us keep our numbers in order. Okay, and then from here, you got to figure out what you're scaling up 6 by to get to 27. And what you're scaling, and then whatever you figure that out, you're going to scale up the 2 by the same amount. So calculator, to find the scale factor, what you're going to scale up by, you have to take 27 divided by 6. And when you do that, you get 4.5. And if you think about it, 6 times 4 is 24. And then 6 times a half, half of 6 is 3. 24 plus 3 is 27. It makes sense. And then we do 2 times 4.5. Well, 2 times 4 is 8. And then half of 2 is 1. And 8 plus 1 is 9. So here's that 9 that we get for batches. So 9 batches, put the unit on it. That's the answer to the prompt. 9 batches of chicken. And then up here we have teaspoons. All right. Okay, so we used a diagram, very helpful to think about how we are going to get answers to these prompts. But again, at the end of the day, I want you to understand how we can use this setup as well and just relate the two. Okay, so on this, first, here's the prompt. It kind of got a lot going on the screen. Here's the prompt. Here's the rate that they're describing. And then we're going to fill out 2 tables first before we do anything with the questions. Okay, so it says to complete the table and use it to help answer the prompts. A bag of candy bar contains 3 Twix for every 5 candy bars. There's 3 Twix. So I'm going to circle Twix. That's a unit for every 5 candy bars. That's your other unit. So we're comparing how many of one type of candy bar is in a bag that has a variety of candy bars. So when we fill out our table, we start with 0, 0. I didn't mention that on the line diagrams. We always start with 0, 0 because if you have no bags of candy, you're not going to have any Twix or candy bars altogether. So it makes sense that our number line start at 0, 0. And we're not going to have any negative values because you don't have negative candy bars. So we start at 0, 0. And then we take the rate we're given, which is Twix, 3 of them, to every 5 candy bars. So I'm going to put it in here, and then I'm going to build my table. And I'm not going to get the unit rate on this. I'm just going to use the rate they're given, and I'm going to say, hey, if I go in order and I have 3 and I want to double that, I want to have 6 of them, I need to end up with 10 candy bars because for every 5 candy bars, I'm going to have 3 Twix. So if I have 10 candy bars, I double this, then I'm going to have double 3. Now, if I want to end up with 15 candy bars, if I end up with 15, 5 times 3, then up here I'm going to triple 3 and I should have 9 Twix. According to this rate, every time I have 5 whole candy bars in a pile, I will have 3 of those will be Twix. Okay, so if I end up with 20 candy bars, I should end up with 12 Twix. And if I end up with 3 times 5, 5 times that amount of the candy bars, which is 25 candy bars, I should end up with 3 times 5, 15 Twix. So every time I throw 5 candy bars into the bowl, I would expect 3 Twix to be in. So 6, 10, 9, 15. These are all, when we reduce all of these, they all reduce to 3/5. Okay. All right, so this table just takes this table and it makes it vertical. So sometimes you get your tables in horizontal rows and other times they come in vertical. And Twix goes first here and candy bars total second. So I'm just going to fill out the same data, but in a vertical pattern. 12 to 20, and then 15 to 25. And then when you're seeing these kind of look like fractions, right? Whoops, got a little crazy there. They look like fractions. They're kind of sitting on top of each other like a fraction. So the table is a good visual for rates for that reason. Here, they're not sitting like a fraction. They're sitting vertically side by side. So it's more like the colon ratio, like this. And so a lot of times you will see them like this. This is a very popular way to write the rates in this format, but you can still scale up. You just say, hey, I'm going to double that. You just do it vertically instead of like a fraction horizontally. So like so. This would be times by 2 in the top, times by 2. Same thing, it's just you can look at it visually up and down. So these are very popular ways to set up the table. Okay, now let's get to these problems. So the first one says, if there's 25 candy bars in the bag, so candy bars is your unit, we're going to circle those units. How many Twix? We're looking for the Twix. So I'm going to go Twix, the candy bars. I'm just going to use B for bar. And there's 25 candy bars, so that goes in the bottom. That's all of them. And oops, we're going to put first the rate they gave us. Start with the rate they gave you. They gave you 3 to 5. So we're basically making a prediction. If there's 25 candy bars, how many Twix would we expect? Well, you can use your table. We've already done it. We scaled 5 up by 5 here. So we had to multiply that by 5. And we multiply this by 5. So this is how it would look without a diagram. So tables are great, but we're eventually going to be just doing them without a table in this format. So we're just kind of practicing how it would look and how it works. So Twix, 15 Twix to 25 candy bars to answer the prompt. You would expect to have 15 Twix. All right, now this next one. If there are 9 Twix in the bag, how many candy bars would you expect to have? So again, it's Twix over candy bars. And we know there's 3 to every 5. That's what they gave us for our rate that we're going to use. And we're trying to figure out if there are 9 Twix, it goes up here, and we don't know the bars. That's what we're trying to figure out. Well, our table tells us right here. And how did we scale that? To get from 3 to 9, we scaled up by 3. So in the bottom, we got to scale up by 3 as well. And that's where that 15 came from. So making a relationship between how we develop this and how this comes about, very important without the table. So you get to see them both today. So you put your unit back onto what you found there, Twix and bars. And then the answer we were looking for was 15 bars. So we got our answer. Okay, this prompt here is saying, hey, if there are 75 candy bars in the bag, how many Twix do you expect to have in that bag? So we're going to set up our unit rate here, or not our unit rate, sorry, our abbreviated rate word form, the T for Twix and B for bars. And then I'm going to fill in my rate that they gave me. That's back over here. Remember, it was 3 to 5. It's in our chart, 3 to 5. So instead of using a table when we read these, we can eventually just set up this proportion and solve without having to do all of that. All right, and we have that there are 75 candy bars, so the 75 goes in the bottom, and the T is what we're looking for in the top. We don't know what the number of Twix are. Okay, so looking at my chart, I'm recognizing that there is no 75 in this table. 75 would be, for the candy bars, would be over here to the right somewhere. But I do have some values that will work very well with 75 because we're creating equivalent ratios, right? I have a 5, and I have a 15, and I have a 25. And these 3 are all factors of 75. They all go into 75 evenly. So I can take the one I'm given here and I can scale it up. You can basically say, hey, how many times does 5 go into 75? It's 15 times. So if I multiply that by 15, I will scale that up. The other option would, and since I have a 5, that's what I'm going to want to do here. But looking at the table, you could have multiplied 15 by 5 to find your 75. Or you might recognize that 25 goes into 75 3 times. So there's multiple ways using the chart to figure it out. When I set it up like this, we're looking at that scale up by 15 using that rate we were given. So again, if you're doing this, this is how I would set it up as a ratio, equivalent fractions. And then put your Twix in the top box because that's what we found for that. Twix was 15 times 3 is 45. There's 45 Twix. You would expect that. If they say, hey, they're going to put 3 Twix for every 5 candy bars, and this is bars. I'm going to abbreviate it as bars. Drop the word candy. All right, so that works here, and the same here. You could just say I'm going to scale that up by 3 if you didn't. If you wanted, you could have used this ratio right here. Instead, you could pick any ratio you want because they're equivalent in that table. I just used the one we were given. It's in the reading, put it down here, set it up, and figured it out. All right, so I'm going to this question. If there are 24 Twix in the bag, so we have Twix to bars again, a little redundant, but we're just going to keep track. And we know it's a 3 to 5 ratio. And they're saying, hey, there's 24 Twix. How many candy bars? I'm going to put my B down here for bars. Fill in my units. How many candy bars are there? So we're going to come over here and we're going to say, okay, no 24. It would be right, whoops, I'm on the wrong side. It would be past the 15. It would be down here in my table somewhere at 24. And we're trying to figure this value out. Over here, it would be to the right somewhere, and we're trying to figure out the bottom number. So looking at my table, there's a bunch I could use. 3 goes into 24, 6 goes into 24 evenly, and so does 12. So I could take any of these ratios right here. They'd be very easy to use in this spot right here. I chose the one that was in the reading initially, and Twix and candy bars, circle my units. I'm going to stick with the 3 to 5. And then what I'm going to do is look to see, what do I have to do to 3 to get that 24? I have to scale it up by 8 times. So that means I got to scale my 5 up 8 times. And I end up with 40 bars. So there you have it. So equivalent fractions, it's great when you have a table because all these are equal, and whatever one you want to use to figure out the prompt, you can pick whatever's easiest for your brain. Or you could just use the one you're given and just work it out that way. If you're given this one, which we were, you can figure out whatever value we're looking for on this side of the chart or this side of the chart that's missing. So the key, why we're doing these diagrams and charts, is really ultimately to get you to understand that we have equivalent ratios going on. And when we have those equivalent ratios, we just scale up and down to find values that fit in that relationship. We're going to scale up by multiplying sometimes, or we need to scale down sometimes and divide. The trick is knowing what to multiply by when you're scaling up, and the other trick is what to divide by when you're scaling down. So that concludes this lesson. You may now go to work on the assignment. Good luck.